next thing we're going to look at is function notation. So function notation is just another way of writing a relation, okay? So far, the only way you guys have really looked at writing a relation is using XY notation. And in XY notation, that just means you are using X and Y. So if we look at the example here, we saw this in the warm-up earlier, or in the review earlier. You'll notice that in XY notation, all this says is Y equals negative 3X minus 2. So we've used the variables X and Y. Okay? In function notation, what we do is, all we really do is replace Y with f of X. Okay? So instead of writing Y, now we're writing f of X. The benefit to using function notation is that it tells you what the independent variable value is going to be. Okay? So it tells you that the function depends on X, and f is just really what the function variable is that we're using. So instead of using Y, we're going to use f of X. Okay? That's all function notation is. It's nothing special. All you're doing is, instead of writing Y, you're writing f of X. Okay? So here's the relation written in XY notation. Here's the same relation written in function notation. You'll notice the right-hand side is exactly the same, and the only thing that's changed is we replaced Y with f of X. That's all function notation is. Okay? This statement and this statement mean exactly the same thing. This is in function notation. This is in XY notation. Okay? The reason why we are introducing you to function notation is because you will be seeing functions throughout the semester. And so this is a notation you'll typically see. You'll see f of X equals and then whatever expression it's equal to. Okay, the way this is read is the value of f at X, or typically the easier way of saying it is f of X. All this means is, instead of using the variable Y, we're using the variable f of X. And what this tells you is, as you plug in different values of X, you'll know what the value of X is that you plugged in, and you'll know what the value of Y is that results as you evaluate. Okay? Now, please be careful. Up to now, whenever you saw one thing next to a set of brackets with an expression inside the set of brackets, you've always looked at that as multiplication. These brackets do not indicate multiplication, so please be careful. Don't start to divide that value of X to get rid of it. You're not supposed to get rid of it. It stays together. Okay? So f of X is just a different way of writing Y, and that's what we're going to be using throughout the semester. Okay, what does function notation do? Well, in function notation, the values of both the independent and dependent variable are clearly stated. Now, let's go back up here for 1 second. Earlier in the review, we looked at evaluating this expression when X is equal to 5. So if I plug in X equal to 5 here, we looked at that earlier, so X is equal to 5. If I plug in X equal to 5 here, and I evaluate, what do I get? I get negative 17. Okay, that was what I was expecting to get. Okay, Y equals negative 17. Now I'm going to do the same thing here, and I'm going to use function notation. Okay, so this is in function notation. Same idea, I'm going to plug in X equal to 5. So wherever I see an X here, I'm going to replace it with 5. So that would mean f of 5 equals negative 3 times 5 minus 2. And so if I simplify this, I get f of 5 equals, if I look at the right-hand side, negative 3 times 5 is negative 15, minus 2 is, oh, look at that, negative 17 again. And now I want you to look at the difference between the final statement here and the final statement here. In this final statement, in the XY notation, all I know is what the value of Y is. I have no idea what the value of X is unless I look up to see what value of X I plugged in. In function notation, in my final statement, I know two things. I know that X was equal to 5, and I know that the resulting Y value was actually negative 17. So the benefit to function notation is it lets you know what the X and Y coordinate of that particular point is going to be. Whereas in XY notation, you only know the Y value in the final statement. Okay? So this is why function notation is better. Okay? Okay, so in function notation, the values of both the independent and dependent variable are clearly stated. So that was like when we had f of 5 equals negative 17. We know that our independent variable is 5 and our dependent variable is negative 17, which results in a point at 5 and negative 17. That's exactly what I was expecting. And that's what function notation, writing the point in function notation tells me. Okay, so for example, f of 3 equals negative 11. What does this mean? It means when the value of the independent variable is 3, the value of the dependent variable is negative 11. Or when the value of x is 3, the value of y is negative 11. Okay? So it sort of indicates that there's a point at 3 and negative 11. That's what that tells me. Okay? So this represents an ordered pair. 3 and negative 11 is a point on the graph of f of x. That's all that means. Okay? Okay, so here's another example. In this example, we're going to be looking at writing the equation or the relation in function notation, and then looking at how to evaluate using it. Okay, so given the function y equals 2x squared minus 6, we're going to rewrite the function in function notation, and then we're going to evaluate it for the values of x that are given below. Okay, so if I want to rewrite this in function notation, all I need to do is replace the y with f of x. So I'm going to leave the right-hand side the way it is, and I'm just going to replace the left-hand side with f of x. Now it's in function notation. That's all you need to do. Okay, now that it's in function notation, we can evaluate the following. What you'll notice here is that this says f of 6. And if you compare it to what we had before, all we've done is replace the x with 6. That's what we're going to do to the right-hand side as well. So we know f of x is equal to 2x squared minus 6, which means f of 6 would be equal to 2 times, replace the x with the 6 since the x here was replaced with a 6. So that would give me 6 squared and then minus 6 at the end. Okay, so all we've done is wherever there was an x in the original statement, we replaced it with a 6. And if I evaluate this using order of operations, I get 2 times 36 minus 6. So that's 72 minus 6, which is 66. Okay, so what that tells me is f of 6 equals 66. And so that tells me there is a point at x equal to 6 and y equal to 66. Okay, let's take a look at the next one. Same idea, we're going to replace x with negative 2. So that's 2 times negative 2 squared minus 6. And again, using your order of operations, negative 2 squared is 4. And then you get 8 minus 6, which is equal to 2. So what that tells me is that there is a point at negative 2 and 2. That's the x-coordinate. There's the y-coordinate. And we know that since f of negative 2 is equal to 2, those are the x and y coordinates. Okay, f of 0, last one. Same idea. Hopefully you get the idea by this last example. And so 0 squared is 0 times 2, which is 0, minus 6, so that's equal to negative 6. So this is f of 0 equals negative 6. So that tells me there's a point at 0 and negative 6. So all function notation tells you is what the x-coordinate is and what the y-coordinate is in one single step. Okay? You don't have to backtrack to figure out what value of x you plugged in. You can figure it out just by the final statements.